Hello everyone, my name is Riski Yosepha, and in this video I will explain the hand letter classification project using the MNIST letter dataset. This project uses hook feature extraction technique and support vector machine algorithm and use model evaluation with LOOCV and grid search CV technique for parameter tuning. Okay, the first time I called pd.read_csv with name file is omnislettertrend.csv without header equals none. The column name were coupled like 0.1, 0.2, and etc. And after I adding header equals none, the column format is correct 0 to 784 with column 0 as the label and 1 to 784 as the 28 times 28 pixel. First I use first First I use the MNIST letter dataset which consists of image capital letter E to Z represented by number labels 1 to 26. The dataset consists of 784 pixel feature from a 28 times 28 grayscale image image plus one column of label at the beginning. Since the CSV file has no header, I use pd.read cfc 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 header equals none to read the data. Okay, next, this code this code this code to show that your dataset is loaded and both have 785 columns. One column of labels or letters A to Z represented by number 1 to 26 and 784 column of pixel values 28 times 28 grayscale image. Then I mark the data. This code, um, the marked result is safe and suitable if you want a random sampling of available data. This code efficient and correct way to generate a balanced dataset with 100 samples per class or 26 letters times 100 is equal to 1,600 total samples. After combining the training and testing data, I balance the data by taking 100 random sample for each class, making a total of 2,600 samples. This is important so that the model is not biased towards certain letters. Okay, Hawk. Next, I separate the future, the labels. Then I reserve the future into 28 times 28 so that they could be processed by the histogram and oriented gradient or Hawk method. Next, okay, for model evaluation, I use leave one out cross validation or LOCV in the previous cross score function, and also 10 hold 10 hold tenfold cross validation when tuning SVM parameters with grid search CV. LOOCV means that each data is used once as task data and the rest as training data. It is very accurate but comput- computationally expensive, suitable for small data sets like this. Um, as as for parameter tuning, as for parameter tuning, I use tenfold CV to evaluate 36 candidates or evaluate 36 different parameter combinations. So a total of 30, 360 training runs. And uh, for Hope Future, extraction, I use the following parameter: pixel per cell, uh, 4,4, and cell per block, 4,4. The goal is convert each image into a feature vector that represents the direction and intensity of edge, which is very useful for letter classification. And for support factor machine SVM, I use grid search CV with the following grid parameter. This code This code resulted in 36 model combinations that were tested one by one. Uh, okay, the C3 gamma 0.03 and kernel RBF, the best cross-validation accuracy result is about 81 it, uh, 81.7%. This show that the model is quite effective at distinguishing hand letter from grayscale image. With this task model, I can keep the model predict new letter or even extend into large datasets. In conclusion, this project involves various stages from data pro processing, future extraction with whole SVM model tuning with grid search and accurate evaluation using LOOCV and tenfold cross-validation. Thank you for listening. I hope this explanation is useful. If you have any question, please have a comment and see you soon.